right, in this video we're going to be looking at how to evaluate inverse trig functions specifically. And so I'm going to do some examples on a sheet of paper, and then after that I'll go through and I'll show you some problems on the worksheet that I gave you for homework. So we can go ahead and write evaluating inverse trig functions. And before we get started, we're going to go ahead and add some things to our unit circle. So on your unit circle, we know that when we have answers that are in the fourth quadrant, according to the video that we did that discussed where the inverse functions come from and where their limited domains are, we know that the answers for sine inverse and tan inverse can show up in quadrant 1 or 4, and we know that the domain is from negative pi halves to positive pi halves. So that means that when we get an answer in quadrant 4, we are not going to say 11 pi 6 is our answer. We're going to use the negative version of the angle instead, and we're going to say negative pi 6. Instead of 7 pi fourths, we're going to say negative pi fourths. Instead of 5 pi thirds, we're going to say negative pi thirds, and instead of 3 pi halves, we're going to say negative pi halves. So I went ahead and I labeled these, and I did it in a different color so it would stick out a little bit for when I'm working on this assignment. So make sure you have those negative angles labeled because they will be helpful. And then up here, I went ahead and I just reminded myself that cos inverse answers can only be found in quadrant 1 and 2. Sine inverse and tan inverse answers will only be found in quadrants 1 and 4. So I put that on my unit circle so that as I work on these problems today, but also in the future when I might not be remembering things as well, that I have those things to trigger my memory. Okay, so we're just going to do a bunch of examples, and then I'll go through and I'll show you guys some that are on the worksheet at that point. So first example, we're going to go ahead and look at cos inverse of 1. And cos inverse of 1, since it's a cos inverse, that means we're looking at the top half of our unit circle. We're looking at quadrants 1 and 2, and it's of 1, so we are looking in quadrants 1 and 2 to see where the x-coordinate is a positive 1. And that happens right here. So it's 0 or 2 pi, but I know that the answers for cos have to be between 0 and pi. So I'm not going to use the 2 pi coterminal angle. I'm just going to say that this equals 0. So right here equals 0. All right, for the second example, I'm going to find arc tan of square root 3 over 3. And arc tan is just another way of saying tan inverse. So for tan, I have to look at quadrants 1 and 4. And so I am covering up these two, and I'm looking where the y-coordinate divided by the x-coordinate becomes positive square root 3 over 3. So since my answer is positive, I know that I have to be dealing with the first quadrant, not the fourth quadrant, because tangent is negative in the fourth quadrant. So I'm going to look only at the first quadrant. The first quadrant, if I'm looking here, I know that this x divided by y, or sorry, y divided by x is not going to work. This y divided by x is not going to work. This y divided by x is not going to work. So I'm focused in on these 2 points right here, and I'm thinking which y divided by x is going to simplify to be square root of 3 over 3. So I know it's not this one because this would be square root 3 over 1, which would just be square root 3. This one right here would be 1 divided by square root 3, which would then have to be rationalized. And so that means that my answer here is pi over 6. All right, the third example, we're going to look at cosecant inverse of 2 square root 3 over 3. And here, I'm not even going to look for that answer right now because cosecant is not one of the x or y coordinates on the unit circle. So I'm going to say, nope, I'm not looking for this problem. I'm actually looking for sine inverse of the flipped version of that fraction. So as soon as I switch it from cosecant to a sine, that means I have to flip this fraction. And this is not a value that I'm going to be finding on the unit circle because it has a radical on the bottom. So I'm going to go ahead and fix that fraction. I'm going to multiply by square root 3 on the top. I'm going to multiply by square root 3 on the bottom. And on the top, that gives me 3 times the square root of 3. On the bottom, I have the 2. And that 2 is being multiplied by the square root of 3 times the square root of 3, which is the square root of 3 squared, which is just 3. So I can see that I have 3 over 6, right? 2 times 3 is 6. But I can also see that these 3's should be canceling. So that gives me square root 3 over 2. So that means that this evaluation I'm really doing is actually sine inverse of square root 3 over 2. Now, some of you guys might have picked that out right away because you've done the simplifying enough to know, like, oh, if I take this and I flip it over and I fix it, this is the fraction I'm going to get. So if you recognized it and you didn't want to do any of this work, you just wanted to go straight here, you could do that. That would be fine. So sine inverse is quadrant 1 or quadrant 4. Since the sign is positive, we're going to look at quadrant 1 because in quadrant 4 the signs are negative. And so I'm looking for a y-coordinate that is root 3 over 2, and that is positive pi thirds. Okay, let's do another example. I'm going to look at sine inverse of negative square root 2 over 2. So this one is just sine. That means we can go ahead and just start by looking at quadrants 1 and 4. Since sine is negative, that means we're specifically going to focus in on quadrant 4. And if I look in quadrant 4 for a negative y-coordinate that is negative root 2 over 2, that's right here. And it's where we have 7 pi fourths. But since I'm dealing with inverse functions, that cannot be my answer. The answer that I have to use is negative pi fourths. So this equals negative pi fourths. All right. Let's go ahead and try secant inverse of negative square root 2. So again, this is 1. Secant is not what I can see on the unit circle, and so I want to go ahead and fix this. Instead of thinking of secant inverse, I'm going to think of cos inverse, and I'm going to take this and write it as a fraction, so that now that I'm thinking of it as cos, I can flip that fraction. So I have 1 over the square root of 2, and this whole fraction is negative. And again, that's not what I'm going to see on the unit circle, so I'm going to take 1 over square root of 2, I'm keeping the negative sign in the front, and I'm going to multiply this by square root of 2 over square root of 2, and that gives me negative square root 2 on top, and just 2 on the bottom. So this evaluation is really saying, please evaluate negative square root of 2 over 2. And if I take that, I'm going to look at my unit circle. And since I have cos inverse, that means I'm looking at quadrant 1 or 2. And I'm looking for where the x-coordinate is negative root 2 over 2. And that is definitely in quadrant 2. And that is 3 pi fourths. All right, so what I would like you guys to see next is I want you guys to understand how we could check this on our calculator. And so if I look up at the first problem, I'm going to make sure that my calculator is in radians because we've answered all these problems in radians. And then after that, I can go ahead and start typing these in to check them. So cos inverse is if you do secant cos. So secant cos of 1 is 0. That was easy to check. Arc tan is just tan inverse. So I have tan inverse of square root 3 divided by 3, and that equals that decimal. And so I'm going to compare that with pi divided by 6. And the decimals are the same, so I know I got it right. With cosecant inverse, you cannot plug in cosecant inverse into your calculator because there's no cosecant button. So to be able to plug it in, we have to do sine inverse, and you should be able to type in either one of these. So if I did sine inverse and I wanted to type in 3 over 2 square root 3, and then type in pi thirds to make sure I got the right answer, my decimals match. I also want to double check this sine inverse one right here because we got a negative answer. So this is what I was saying, is that when you take sine inverse, the answer is going to give you negative pi fourths. It's not going to give you 7 pi fourths, even though that's a coterminal angle. So if we look here, if I was to do sine inverse of negative square root 2 divided by 2, you can see that it gives me that negative decimal. So it did not give me 7 pi fourths. It gave me negative pi fourths. So you always want to make sure that you're keeping in mind that for cos inverse, you're only using quadrants 1 and 2. And for sine inverse and tan inverse, you're only using quadrants 1 and 4. And that if you have a quadrant 4 answer, it has to be the negative version. Okay, so if we look at some problems now on the worksheet, you're going to find that these are pretty straightforward. So for number 1, it says arc sine, which is just another way of saying sine inverse. So I'm looking in quadrants 1 or 4, and I'm looking for where the y-coordinate is positive, and a positive 1/2, and that happens at pi over 6. For arc tan of 1, sorry, that cord is annoying me. For arc tan of 1, we were looking for where, in quadrants 1 and 4, where the y value divided by the x value is going to equal 1. So since it's a positive 1, I know I'm looking in quadrant 1, because quadrant 4 has negative values. And I'm looking for where a y divided by x, where the numbers are the same, so they're going to cancel out to be a 1. So that means that I'm looking right here. Y divided by x, that's the exact same number divided by itself, so that's going to equal 1. So this is pi fourths. If I'm looking at tan inverse of negative 1, I'm saying this time I want the exact same number so they cancel out, but they do have to be the opposite sign. So here is where I'm going to look in quadrant 4 at the same point. I can see that they're the same number, so they're going to cancel out, but one of them was negative, and so my answer here is negative pi over 4. All right, I also wanted to talk about a composition of inverse functions. So that means that you have more than one inverse function that you're dealing with. And so we're going to look at cotangent of sine inverse of 1/2. So there are two things going on here. So the first thing that you do is you look at the inside of the function. So you work from the inside out, which is exactly what order of operations tells you to do when you do PEMDAS and you do parentheses first. It tells you that when you're working with evaluating a function, you start on the inside. You simplify from the inside out. So if we look at sine inverse of 1/2, we're looking in quadrants 1 or 4. I'm looking for a y-coordinate that is 1/2, and that happens right here at pi over 6. So that means that pi over 6 is actually what is represented inside of that function. So now I'm going to say I need to find cotangent of pi over 6. And cotangent of pi over 6 is going to be the x-coordinate divided by the y-coordinate. So I have root 3 over 2 divided by 1/2. I know that those 2's are going to cancel out. So I have root 3 divided by 1, which is just square root of 3. All right, and we've got one last example to finish out the video. I'm going to do secant of arc tan of 1. So again, we're going to work from the inside out. So arc tan of 1, looking in quadrant 1 and 4, and I'm looking for where my y-coordinate and my x-coordinate are the same, so that when you divide y over x, you get 1. And so that happens right here at pi fourths. So I'm going to go ahead and say that this right here actually is pi fourths. I'm doing my order of operations, so I did the inside first. Now I can go back and do secant of that simplified inside. And so secant of pi fourths is where I take the x-coordinate and I write the flipped version. So this is 2 over square root 2. And I do need to fix that. I need to rationalize the denominator before I can make a conclusion about my answer. So on the top, I have 2 square root 2. On the bottom, I just have 2. The 2's cancel, and square root 2 is my answer. All All right, these are a little bit harder to plug into your calculator, so I'm going to go ahead and show you guys how we could do that. Cotangent, you're not able to plug in cotangent, so instead of cotangent, we plug in 1 divided by tangent. So I'm going to make this a fraction. We have 1 on the top, tangent on the bottom, and the stuff that I'm taking tan of is the inverse of sine of 1/2. Okay, so that's cotangent of sine inverse of 1/2. And I get 1.732, which is the same as square root 3. So my answer checks out. For secant of arc tan of 1, I have to do 1 over cos instead of secant. So I'm going to go ahead and do 1 over cos, and then arc tan of 1 would be tan inverse of 1. And that gives me 1.414, which is the square root of 2.